we focus, please, guys? I don't like having to tell you to keep quiet every 5 minutes. All right, we've done these types of graphs so far. So y equals sine x, a sine x plus q, sorry, and y equals a cos x plus q, and y equals a tan x plus q. Those are the ones that we are familiar with. And from those graphs, we know that the period of sine and cos is the same. So I'm just going to group them together like that. We know that the period is 360 degrees. And then we use that period to get the step. All right, so the step, which we remember is the distance between plotted points. The step is always 360 because that's the period divided by 4. So that is then equal to 90 degrees. So that is why we plot a point, or we have an asymptote, or whatever the case is. Well, for these ones, we won't have asymptotes, but for the sine and cos graphs, we will plot a point every 90 degrees. Okay, then tan is the odd one out. We know that the period of this type of tan graph is 180 degrees. So the step will then be 180 divided by 4, which is then 45 degrees. So for a tan graph, we plot a point or we have an asymptote. Something happens every 45 degrees. Now we are introducing a new variable, right? A new parameter, we call it, because it affects the graph in some way, and that is k. All right, so now we are going to have something like this, a sine kx plus q. All right, that k will be the coefficient of x. You'll see when we're doing examples. Same thing with cos. K is now a number that will be written in front of the x. And then the same with tan. Now, guys, I just want to show you a diagram that is in the notes. We're not going to redraw the diagram. I just want us to discuss it quickly. So I'll put this up just now again. What they have here is, let us consider y equals sine 2x. Now, the 2 is written in front of the x. So we'll say that for this one, k is equal to 2. Don't worry about copying this down. We are going to draw some examples. Okay, we're just kind of discussing it. So our k value is 2 over here. Now, what they've done is they've used their calculator. Now, guys, remember for a sine graph, which I told you also yesterday, if you want to use the calculator, you would sub in x equals 0. Then what would the next x value usually be that you would sub in? 90. So see what's going to happen if you were to do that here. If you sub in x equals 0, you're going to say sine of 2 times 0, you'll get 0. Then you'll sub in 90. You'll get sine of 2 times 90, which is again 0. Right? Then the next one that you'll sub in would be 180. Okay, this is our usual step, the step that we've been working with all the time. And again, you'll get 0. The next value that you'll sub in would be 270. Again, you'll get 0, and the same thing with 360. So what do you have there? Do you even know what the shape looks like if you just have a bunch of zeros, right? Yeah, so it will have to, but this is unusual, right? Normally for a sine graph, we have 0 and then 1, and then 0 and then -1, and then 0 again. All right, but now if we have sine of 2x and we sub our normal step values in, our normal x values, we actually just get a bunch of zeros, all right, which is different. So what they've done is they've taken the in-between x values as well. Halfway between 0 and 90 is 45. Now, do we see that at 45, we're getting a y value of 1. This is what we would normally get for 90. Now we're getting it at 45, right? Halfway between our usual distance. Normally, we would get -1 at 270. Sorry. Normally, we would get -1 at 270. Hey. So here they've drawn the normal sine graph. Let's just quickly remind ourselves. We have 0. Then at 90 degrees, we normally have 1. All right. So this is just sine x. At 180, we usually have 0, but then at 270, we usually have -1. Now, for sine 2x, we're getting -1 at 135. Do we see again that's halfway between 0 and 270, halfway between the normal distance? So what they've done here is they've subbed in the halfway values, and they've actually plotted those points. So at 0, we're getting 0. At 45 degrees, we're getting 1. At 90, we're getting 0. At 135, we're getting -1. And at 180, we're getting 0. Now, guys, do we see that this is one full sine curve, actually? Right? And what is the definition of a period of this type of graph? The distance or how long it takes for one full curve. Usually it's 360 degrees. Now, do we see that it's actually 180? It only takes 180 degrees for a full sine curve to actually happen. All right, so that is what the 2 does. The 2 in front, sorry, let me show you here. The 2 in front is actually halving the period. The period of y equals sine x is 360. If we're plotting the points, we see that the period of y equals sine 2x is 180, half of the original period. All right, so from this sketch, we can see that the period of y equals sine 2x is 180 degrees, half of the basic sine graph's period of 360. So the value multiplied by x, the coefficient of x, the number in front of x, which we have called k. Oh, here they're saying is commonly indicated by using the letter k. It doesn't have to be k, but we just use k. It's also used in the textbook. Multiplying the x in the equation by a constant by a number other than 1 changes the original period of the graph. Okay, here they've listed it. For example, in y equals sine 2x, the x is multiplied by 2. Our k value is 2. So the period becomes 180, which is the same as 360 divided by 2, divided by that k value. We are going to write this down. Then we could also look at this one, y equals cos of a third x. Now, what is our k value here? What number is written in front of x? 1/3. Now, guys, if you were to draw this graph, if you were to plot values and actually draw that graph, you would see that the period would actually be 1080 degrees, which is very big. That is how long it would take for that cos graph to repeat, or to complete itself for the full curve. Oh, I'm speaking very democratic today, sorry. So this would be the new period, all right? And you would also get that by taking the original period, that 360, and dividing it by your k values. Right, so that is what we're actually going to have to do. Whenever we see that we have a number in front of x, a number that's not 1, our period is going to be, for sine and cos, the original period divided by whatever that number is. Whether it's a whole number or a fraction, it doesn't matter. You're going to get the new period by dividing the original period by k, by that number. And what does that mean for our step, guys? Are we still going to say 360 divided by 4 for the step? We're going to take our new period, whatever it is, and we're going to divide that by 4. All right, so I'm just going to write here, our step is going to be 360 over k divided by 4. I'm not going to write that as a fraction because then it's going to look a bit hectic. All right, but whatever the new period is, that is what you're going to divide by 4, and that will give you a new step. So guys, we can't now just automatically say, I'm going to have a point every 90 degrees. All right, it might be different. We'll do some examples. For the tan graph, we're going to do the same thing. Our period is now going to be, what is the original period of a tan graph? Of the basic tan graph, it is 180. So it's going to be 180 over k, whatever that number in front of x is. We're going to take the basic period and you're going to divide it by that number. And your step will then be that period, the new period, divided by 4. Okay, I want us to do some examples quickly. Sorry. So you can just write here examples. Okay, we're just going to draw two graphs. So we'll start with y equals cos 3x for x element of 0 to 360. So guys, if we're looking at this equation, this formula, this graph, what is my amplitude? 1, hey? The number in front of cos 3x, the number, our a value is 1. So that means that the amplitude is going to be 1. We can write that there. So our amplitude is not changing. Okay, it's just the basic cos graph. It's going to start at 1, then go down to -1, and go back up to 1. Okay. Do we have a shift? Is this graph shifting up or down? Is there a Q value? No. Okay, so I'm just going to write here, no shift. You don't really have to write it there when you're doing this yourself, but just because it's the first example. But we do have a K value here. That is something other than 1. Okay, it's not just y equals cos x, it's cos 3x. So our K value is 3. So that means that our period is going to be our normal period, all right? The period of a basic cos graph, which is 360 degrees, divided by 3. And what is that? 120. So guys, it's actually only going to take 120 degrees for a full cos curve. So how many full cos curves are we going to have in 360? 3 of them, hey. So we're actually going to have to draw 3 cos graphs altogether if we're going from 0 to 360. Now, if our period is 120, then that means that our step is going to be 120, the new period divided by 4. And that is 30 degrees. So guys, for this one, you're going to have to plot a point every 30 degrees. But it's going to follow the normal shape of a cos graph. So your first point is going to be the point at 0, 1. Then your next point, instead of being at 90 degrees and 0, it's going to be at 30 degrees and 0. Okay, so you don't have to rethink the shape. We all know what a cos graph looks like. It's going to have that exact same shape. Just instead of 90 degrees between our points, we're going to have 30 degrees between them. Okay, let's draw some axes here. We're just going from 0 to 360, so we don't need a negative x-axis. So we can just draw our y-axis. Sorry, this book is slipping and sliding. Just draw the y-axis like this. Now we need to go from 0 to 360, but we need to have a point at every 30 degrees. Now, guys, this is something that you need to figure out in class. You need to actually draw your own axes. But remember, in a test or exam, they give you the Cartesian plane. Okay, you're not going to have to worry about how long you're going to draw your line for and whatever. I actually think I'm going to use a centimeter for every 30 degrees. All right, that's what I'm going to do. Yeah, we'll fit it in. Yep. And then just make it a little bit longer so that it doesn't end on 360. Well, because they've just said from 0 to 360, but if they said -90 or -180 or whatever, then you would obviously have to, yeah. You can draw like a short -1 if you want, but it's fine. You don't actually have to. Yes. Okay, so this axis is going to be a bit busy, but I am writing every 30 degrees on my axis because that's my step, hey? That's how often I'm going to have to plot a point. Okay, just from 0 to 360 every 30 degrees. You can just count on in 30s there. Yes. For the turning points, yes, but not for the ones on the axes. So for the one at the top and the one at the bottom. Yeah. Guys, if you're ready, you can draw your graph. It's going to have the same shape. It's just going to be 0, 1 at 0, and then at 30, then 60, and so on. All right, it's going to have the exact same shape. You can do that on your own if you feel ready to. Very nice, yeah. They can give you like a fraction as well. In tests and exams, usually they are quite kind. They won't give you one that's too difficult to work with. But the textbook is quite hectic, which is why I tend to not really work from the textbook. They give, not nice numbers to work with. All right, guys, where does a cos graph normally start? We know the shape of the cos graph. It starts at the highest point, eh? And because the amplitude is 1, the highest point is going to be 1. I should rather say because the amplitude is 1 and we're not shifting up or down. Okay, starting at 1. Then our next point is at 0. Next point is at -1. Then we go back up to 0 and then back up to 1. Do you see that that is one full cos curve? When we're actually going to draw our curve in, that will be one full cos curve. And the period is 120 degrees, guys, and it's supposed to take 120 degrees for one full curve. Right, then we basically just mimic or we copy the pattern from there. So we keep doing a whole up down thing. And at the end, we are supposed to have 3 full cos curves all connected. Okay, I'm just going to freeze so that I can turn my book to draw this in. You're starting at 1, which is the top. That would be the top part. Yeah. And then, guys, all your turning points you're going to have to label with their coordinates, please. So do that as well. Oh, yeah, I suppose that would kind of be like the third one if you put them together, yeah. So guys, if you want to, you can just make a little note. I'm just making a little line there at 120 and then 240 and then 360. Right, that would be one full curve from 0 to 120. Then we would have another full curve from 120 to 240 in the next 120 degrees, which is our period. And then our third full curve would be there. Okay, we're going to do another one quickly. We're going to do y equals tan 2x But this one we are only going to draw from, let's do negative 90 to 180 for a change. Right, so then we're going into the negatives as well. Okay, guys, for this one, our A value is 1. All right, so it's not reflecting and it doesn't have a different, remember, its hand graph doesn't have an amplitude, but it can stretch. So that first point, well, we're going to start at 0, but then the first point would be at 45, 1. All right, that's the normal thing that we're having. This graph also isn't shifting up or down, but we do have a K value. So the period is going to change. So period, we know that the period of a tan graph usually is 180 degrees. We now need to divide that by 2, which is our K value. So the period is going to be 90 degrees. All right, so it's going to take 90 degrees for one full tan curve to happen. So guys, if we're going from negative 90 to 180, how many 90 degrees are there in that interval? Okay, 3, right? From negative 90 to 0, then 0 to 90, then 90 to 180. So we're also going to have 3 full tan curves on this graph. Once we know our period, we can find our step. So the step is now the new period divided by 4. So 90 divided by 4. Now this is actually going to be 22.5 degrees. But guys, you're going to have the same shape. All right, just like here when we did the cos graph, it follows the same shape. It's basically just the distance between the points, between the things that we normally plot, that is different. So now instead of having our first point at 45 and 1, it's going to be at 22.5 and 1. Right, it's just the distance that changes. All right, so let's draw our axes here. Let me just quickly think. Negative 90 to 180. Okay, I think I'm going to use 1 centimeter again for each of these steps that we have. All right. Okay, this long one is going to be my y-axis. Oh, I actually didn't make it nice and long, but anyway, it's too late now. Did I make it 1, 2, 3 now? Which maybe times 2. Okay, wait. Negative 22. Yeah. Sorry, guys. 2 there. I'm gonna have to add some on the X one as well. Let me just check. 135. No, this one is fine. Yeah, sorry, I just made 1 too few over here. I'm not going to write in the middle ones because then it's going to be too close. All right, but we will, when we have to plot those, we'll put them in. Right, you can start plotting your points if you want. We're going to follow the normal shape of a tan graph, and since this one is not shifting up or down, it's going to start at the origin still. Then the next point is just going to be at our next step, which is now 22.5. So that's going to be at 1. And what normally comes after that point on a tan graph? The asymptote. Okay, so now our asymptote is actually going to be at 45, guys, not at 90, which is what we're used to. Right, this first asymptote over here is going to be at 45 degrees. After our asymptote, we have a point at -1. Then we again have a point at 0. Now, guys, that is our tan curve. All right, this positive half, an asymptote, and the negative half. So now we're just going to repeat the pattern in the next space that we have. Right, so after the point at 0, we have a point at 1 again. And then we're going to have our next asymptote. After the asymptote, you have your point at -1 and then your point at 0. Now for the negative part, we have to repeat the pattern like going backwards. So if we have a point at 0, before that point, we're going to have a point at -1. And then we have an asymptote. Then you have a point at 1 and then again a point at 0. Right, let me just draw that in and then you'll be able to see it a bit clearer, I think. Okay, and then each of these, they're not really turning points in this case, but all of those points that are not on the axes, yeah, you would have to label. So what is this now? -67.5. Remember your step is 22.5 degrees, hey? So you have to add that every time to get the other values. You might have put them on your x-axis, and it would obviously also be easier. So this is going to be 112.5, the next one. And then 140, 57.5. Yeah. Yes. If you leave them, if you leave it out everywhere, you'll only lose 1 mark. But I mean, yeah, you will lose a mark overall. So it kind of depends on who's marking. Some people are more, but you are supposed to lose a mark, yeah. All right, guys, so this period change thing, it's actually, I find maybe even easier than the other shifts that you've done already, because it's the exact same shape. It's just the distance between the points that is less. Now, if you want to use the calculator, like I showed you yesterday, you're welcome to do that, but you're going to have to know your step in order to use the calculator efficiently. All right, if you just see, okay, it's a tan graph, I'm just going to sub in x values, and you sub in your normal values of 0, 45, 90, 180, and so on, 270, 360, you're not actually going to get the points that you're needing. All right, so if you want to use the calculator, that's fine. You can also just do that to check if you're not feeling 100% sure about the points that you're plotting, but you're going to have to sub in every 22.5 degrees. All right, not every 45 degrees like we're used to with the tan graph. So you will have to do this thing where you say, okay, the period is now 180 divided by 2, and your step is then that divided by 4. And then these are the values that you're going to have to sub in on the calculator. All right, so you will have to actually understand that concept of K changing the period. Okay, I'm just going to give you some to practice on your own. I'm not going to draw more examples now. Let me just see here. Okay, guys, I'm going to give you a mix of like the previous ones as well, and then the new ones. And I'm also going to change the domain now. It's not good for you to just practice 0 to 360 all the time because it might not be that in tests or exams. So we'll do this one again, negative 90 to 180. Okay, this is the last one that I'm going to give you. Well, guys, please notice that the only one where there is actually a period change is number 4, but there are also other things happening in number 4, all right? So it's reflecting in the x-axis and it's shifting 1 unit up. All right, so see if you can do that one. The other 3 are like the ones that you did for homework yesterday. Okay, you can get started on that. You still have 12 minutes, so you can at least draw the first one, maybe the first 2 in that time. Yes.